Okay, this is the Singapore Sports School Prelim Exam 2019 Chem paper. So I'll attempt to go through the mistakes only. So the first question with a mistake is this question 3. It's regarding the last part for the ionic equation. So there is, you basically wrote the neutralization, the ionic equation for the neutralization. Yeah, but I have no idea which one this refers to. So according to the answer, then this is copper sulfate, this is copper oxide, and then this is metal oxide, E is calcium oxide, D is calcium sulfate. Then G is water, then F is calcium hydroxide, then what else? A is copper hydroxide. So I'll pick anything that I think it's easy to do. So B to A, process B to A is quite easy to get. Then D to F is also quite easy. So you get B to A. This one is copper sulfate solution, which is aqueous plus sodium hydroxide NaOH. This is aqueous also. Then you'll get copper hydroxide, which is solid, then plus sodium sulfate, which is also aqueous. So ionic equation for this one would be you splitting up. Let's balance first. Then 2OH copper. So after balancing the balanced chemical equation, then we will split up the ions. Those that are aqueous, we can split it up. So 2Na plus 2OH minus. You will get copper hydroxide plus 2Na plus sulfate. Then you strike out the ones that are common. So you strike out this. Then you strike out the sulfate here. Then you'll be left with copper 2 plus 2OH minus gives you copper hydroxide. That's one. Then next one I would do process D to F. It will be somewhat similar. So you get calcium sulfate plus NaOH gives you Na2SO4 plus CaOH2. So this is also solid. Then you have this equals and then this is solid. So you get balance here, calcium and sulfate like this. So you speed up the ones that are ionic, so the ones that are soluble, the equals one. Then you get Na2Na plus SO4 minus plus calcium hydroxide. So you strike out this and this, and that's about it. So it's about like this. Then as for reaction for acid to B, right, the blue solution, what happened is you have H2SO4 plus copper oxide. So this is aqueous and then this is solid. So you'll get copper sulfate plus water. Copper sulfate is aqueous, water is liquid. So you need to balance again. One oxygen, two oxygen, then copper here, sulfate here. Okay, so then you split it into ions, then you will be like this. Plus CuO gives you Eu2 plus SO4 2 minus plus water. So this cancels out with this, so it becomes 2H plus CuO gives you Cu2 plus H2O. Because it's ionic equation, you need to put in the state symbols. So I believe from acid to E, right, it will be similar reaction with acid to B. So I shall not write the equation anymore. Then this is for part D, part 1. Here on the Earth, you have, besides sulfur dioxide, nitrogen oxides are also found on the atmosphere, in the atmosphere, whatever you call it. So explain in brief details how nitrogen oxide comes about on Earth. Okay, so you find them in the internal combustion or engines of cars. So that comes from combustion, that is the same point. So then you need to say that the high temperatures of car engines will cause nitrogen and oxygen to react. So that must be written. Then when you talk about lightning activities, then you say that nitrogen and oxygen comes in to react because of high temperature is fine too. So that's the only thing I want to add of car engines causes nitrogen and oxygen to react. One mark. And this is the other mark. So these are how the marks are allocated. Then this is five part C. So the question asks, sulfur dioxide decolorises potassium, acidified potassium manganate 7. So then they ask, what can be said of its nature? Its nature meaning whether it's oxidizing or reducing, that you get it correct. Then after that, then your statement, I mean, it's questionable is because your answer is kind of questionable because you say, hence, since sulfur dioxide decolorises acidified potassium manganate 7, then it is a reducing agent. I think it's not very legit. I mean, you have to first say that potassium manganate is a strong oxidizing agent, or you say that the oxidation state of manganate, or rather manganese, changes from a certain value to another value, so that it shows that the potassium manganate 7 has been reduced. Therefore, sulfur dioxide is a reducing agent. So let's look at the mark allocation. They say sulfur dioxide is a reducing agent. This is 1 mark. Then we say that the oxidation state of manganese changes from +7 in KMnO4 to +2 in Mn2 2+. This one is 1 mark. So I will add at the end, then you say since sulfur dioxide causes reduction in, therefore it is a reducing agent. I will word my answer in this manner. 6A, then you have part 1, then they ask for the approximate pH value of hydrochloric acid. I think pH 1 is better. I mean, not saying that your answer is exactly wrong. That's just what I have to add on. Then 7 part B. 7 part B, you will notice that I made bracket here and I say, so describe the reactions that happens in the blast furnace. Then in your answer, you must include 2 reasons for using coke in the blast furnace. So the 2 reasons is you produce carbon monoxide as your reducing agent. Then the other reason is that you want to, okay, so because when you burn coke, right, it's a highly exothermic process. That means it produces a lot of heat. So it will cause the temperatures in the furnace to increase to a suitable high temperature. So that's the other reason. So you lost 1 point there. Like that. So it brings the temperature of the furnace up. That's the other one that is missing. Then the rest is fine. The rest of the details are all here. Okay, so this one I kind of forgot to mark. Okay, but I would just comment on this right now. So you say crude iron, sorry. Crude iron is also called pig iron. So it's first obtained from the blast furnace. So this form of iron has a high carbon content, making it very brittle. So they want you to use your knowledge of iron and alloys, right, to explain why pig iron is very brittle. So you would say that carbon atoms has a different size compared to iron atoms. That is true. Okay, so then this causes the atoms to not be able to slide over each other. This is all right. But in front here, you should say that the uneven size, right? Atoms, right? Disrupts the regular arrangement of iron atoms. So this causes the atoms to not be able to slide past each other easily. Therefore, it's brittle. So you need to add this line. Then the next one, you say iron part D. So iron with dilute sulfuric acid produces iron 2 sulfate as one of its products. So when aqueous hydrogen peroxide is added to this iron 2 sulfate, a yellow solution is formed. Then you have to explain why this changes. So you have this iron 2 sulfate. Iron 2 sulfate is actually green in color. Then for iron sulfate to turn into something yellow, right? I believe that yellow substance is iron 3 sulfate. Generally, iron 3 compounds are either brown or yellow, depending on concentration. So because of this, right, iron 2 has become iron 3 So oxidation has taken place. Because oxidation has taken place, right, then we must conclude that the hydrogen peroxide is an oxidizing agent. That's what's happening. So if I were to write it, then you say hydrogen peroxide. You want nature, right? So hydrogen peroxide is an oxidizing agent. That's 1 mark. Then because iron 2 ions are oxidized by hydrogen peroxide into iron 3 ions. This one is another 1 mark. For this question 8, you did not do the question. So let's just kind of run through it. Okay, the first part here, it says zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. So they say write the balance equation. So we will write the balance equation. So zinc plus HCl gives you zinc chloride. Zinc chloride is like this plus H2. So which means before the HCl, right, there should be a 2 down there in order to balance. Just like this. Then after that, the reaction or the question continues. They say an investigation was carried out to find out how fast different metals react with an acid. So zinc powder and iron powder were reacted separately with excess hydrochloric acid using the setup as shown below. So the conical flask and the gas syringe, we have the metal powder with the hydrochloric acid inside the flask. So then you see that volumes of gases produced were measured and recorded every 10 seconds. So different experiments were conducted accordingly. So you have 50 cubic centimeter of HCl and 0.15 of zinc. Then the other one is with iron powder, zinc powder, iron powder. Then the last one is 50 cm cube, right, of hydrochloric acid and 0.075 of zinc powder mixed with 0.075 grams of iron powder. Then they gave you this graph that shows that the reaction of zinc is faster and the amount of hydrogen produced is slightly different. Okay. So the first two sets, the result was shown. Okay, with that, let's look at the question. They say, what is the rate of reaction for the first 30 seconds for iron? So you will go to the first 30 seconds. Then you read this reading. So it's about 44. So rate would be the gradient of that line, which is just 44 divided by 30. So it's 1.47 per second, like this. Then the second part, they say predict the total volume of hydrogen formed in the third experiment. So in the third experiment, what happened is we know that there is, for the first and second, we know there is 0.15 of each. So we get over here, this is 64. Is it 64? Yeah, 64. Then the other one is 56. Like this. Because, right, the amount of metal powder is half for iron and zinc in the third experiment, right? So that means this one has to divide by 2 to become 28, and this one becomes 32. So the last part, the total volume will be 32 plus 28. So this will be 32 plus 28 gives you 60. Then part C. Okay, part C, using the mass of zinc, calculate the minimum concentration of the acid used in this investigation. So we have to write out the equation again. So zinc plus HCl gives you zinc chloride and hydrogen gas. Like this. So using the mass of zinc, so we know this is 0. How much again? 0.15 of zinc. Then the amount of hydrogen produced is 56. So what you do is you first find the number of moles of zinc. So number of moles of zinc equals to 0.15 grams divided by 65 equals to 0.0023 moles. This is 1 mole. Then second is you do the mole ratio. So zinc is to HCl is 1:2. So number of moles of HCl will be times 2 of that of zinc. So it becomes 0.00468 moles. So this is half a point. Then mole with this is also half a point. Then after that, the concentration of HCl just means that you take the number of moles divided by volume. So number of moles is divided by volume is, just now we said is, volume of acid is 50. So 50 means it's 0.050 dm cubed. So therefore it becomes 0.0936 mole per dm cubed. Like that. Okay. Then the next part is, they say, how would the experiment differ if the concentration of the acid has doubled? So if we recall, right, so higher concentration means So this is rate of reaction. So a higher concentration means that there is a higher rate of reaction. Simply because there is a higher rate of effective collision in the atoms and particles. Okay, so in that case, right, if we translate it to a reading in the graph, right, that means that the initial gradient of the graph will be steeper. Then what something else? Because the amount of the amount of metal still remains the same. So the excess reagent is actually the acid. So because of that, right? So another thing is because the limiting reagent in this reaction is the metal, not the acid. So that means the amount of gas produced will be the same as before. So in that case, right, the same height where the curve level off, right, is the same. So this is mark 1. Then this is the other mark. Then they say explain your answer for D part 1. I kind of mentioned. You say zinc is the limiting reagent or limiting reactant. So the final volume of gas produced is dependent on zinc. So this is 1 mark. Then higher acid concentration means there is more reactants for greater effective collision. So initial rate will be faster. So this is for D part 2. Okay, this is question 9B, part 1. Okay, so it shows the experiment that is used to determine the trend in reactivity of halogens. So 9.1 records the results. So from the table, you can see that bromine does not displace chlorine from the potassium chloride solution, but it also doesn't displace bromine itself from the bromide solution. Then it only displace iodine from the potassium iodide solution. So that's why you see that it turns brown. Then chlorine has no reaction with potassium chloride, but it displaces bromine and iodine from their respective halide solution. Then iodine does not react with anyone, so no reaction observed if you see the results from the table. So in that case, right, chlorine can be said that it is the most reactive halogen because it displaces bromine from bromide and iodine from iodide solutions. So then bromide, right, because it only displaces iodine, but it does not displace chlorine, then you can come to a conclusion that bromine has a higher order of reactivity than iodine, but it is lower in reactivity than chlorine. So iodine does not displace any of them, so you can say that iodine is the least reactive out of the 3. So you can say this. This itself is 1 point. Then after that, you say that chlorine can displace both bromine from the bromide solution and iodine from iodide solution. Therefore, it is the most reactive. This is 1 mark. Then you can say bromine can displace. So it is more reactive than iodine, but not chlorine. So this itself, because what happened is you write bromine could only displace iodine. So then you say that iodine is least reactive because it doesn't displace anyone. So chlorine is blah, 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 blah. So it will be good if you can, it will be good if you can put bromine not being able to displace chlorine as an indication that it is less reactive than chlorine. So like this one is 1. So you'll see that mark distribution down there, there is actually 4 marks. So 3 marks. So for the last 3 parts, right, that means the explanation for who is more reactive and less reactive. That one, right, you just need to pick 2. So your answer may be okay. I think your answer can get 3 points also if the marker is not so anal about the bromine because you wrote everything down there. Okay, then the balance equation for any reaction. So there's nothing much here actually. So it's actually correct because chlorine displaces the bromine.